So what this really boils down to, because there's a few different routes you could take to graphing this, but I think the easiest way to go about doing this, since all of these are going to be lines, I'm not going to ask you to graph anything other than a line. Notice where this first function starts. It starts at 0. So what would be really, really nice to know is I didn't leave a lot of space for work, did I? Find f of 0. So that simply means, since 0 is defined by this function, take a 0, plug it in for that. So you would just do 1/2 times 0, which is 0. So what that tells us is, at the time of 0, we get a value of 0. So that means this graph starts at the origin. So on your graph, we're starting at 0, 0. Then, since these are all lines, they all have powers of 1 here. All I need to do now to get the next point is go to the end of this interval. So go to 12 and do the same exact thing. So find f of 12. So that means I'm, again, using this function here, 1/2 of x. And I basically want 1/2 of 12. What that then means, go to the x value of 12. So if you look on the x-axis on this, go to the x value of 12. We know our y coordinate is going to be 6. So here's 12. Why is it not blue? And go up to the y coordinate of 6. Right, so 12, 6 is right here. Put that dot. Connect those. I missed. It's not easy to draw this thing. So connect those dots. And then that's our first part. Yeah, Cam? Good question. Yeah, so good question. What this gives you in this one now, if we look at these inequality signs, there's two 12s. So here's what Cam's asking. There's two different 12s, he's basically saying. There's a 12 here, and there's a 12 here. So how do we know to plug it into this one and not that second one? The reason for that is, notice how this one has the equal to sign? Yeah, so that's the one that defines 12. This is open, so we don't want to use our 12 right there. All right? All right, now. Okay, cool. So now we go to this next one. And again, we're going to start at 12. Now, this kind of goes against what Cam was asking, but we do want to start this one at 12 and see what this one gives you at 12. Okay? So take your 12, plug it into that one. So doesn't 3, and then if I do 12 minus 12 plus 6, isn't 12 minus 12 is 0? So I'm just going to get 0 plus a 6. So don't those actually both give us a 6 for these? So we're going to actually start at that exact same point. Let me start this one in red. And then what we need to know is, where does this one finish? So take your 17, evaluate it at 17. Plot that point. So if I now do, come on, you. So if I do 3, 17 minus 12, and then plus 6, that is 3 times 5 plus 6, which is 15 plus 6. That is 21. So what that means is, go to 17. So here's 17 on the x-axis. Go to the point 21. Plot your point. This gives us the second line. Come on. All right, try that third line. So see if we can now get from this point that this line ends at to the new point that we would get in this third line. And then let's see where we're at. What we want to know is at 17, what do we get in this equation? Can't really see green very good, can you? So let's see, at 17, what does this give you? That should be nice, because if I do 17 minus 17, that would give me a 0. Add your 21. This one starts at the same exact point the previous one finished. Where does it go to? Give us whatever we get at 23. So now we have to take this negative and then x minus 17 plus 21, and we have to evaluate it at 23. So let this x be a 23. That should give us a negative 6 plus 21, so that we end up with a 15. So what that now means, plot the point when we had the x value of 23. So go to your x-axis at 23. We're plotting the point at 15. All right, so 23, 15 should be right here. Connect that, and then that's our third one. And then our final one, red. Notice what's going to happen in this one as well. If we start this one at 23, if I plug a 23 in for that quantity, doesn't the quantity just become 0 plus 15? So that one's going to start right where that previous one ended. So the last thing we need is what value do you get at 25? All right, so take that, plug your 25 in, plot that point, and then we should then be able to connect those dots. Let me get my other pen. All right, so let your x become 25. We're doing 3 halves, and then 25 minus 23 is 2. So what should happen nicely right here, these 2's would just cross cancel, leaving you with a 3 plus a 15, so that if we get an 18, then we know we did that one correctly. So go to 25. So here's 25. We go up to 18. And then that's our graph. All right. There's some other ways to go with like slopes and all of that, but then we got to know when to stop. To me, I think this is the nice kind of easy way to go about doing this. Okay. We're going to practice this a little bit on Tuesday as well. We did these before the break and they weren't so good. And definitely want to make sure we can do this by Wednesday. Okay. All right. So now A and B, do your domain. Domain we better be able to do. There's a couple different routes you could take. You now have the graph to look at, or you can look at your function. So write your domain. All right. And Jenna, what do you think for our domain, Jenna? Good. She said 0 to 25 with brackets. Did you do it with the graph or did you do it with the function? Okay, so she said she did the graph. She looked at the graph and saw that we started at the x value of 0 and it finished over here at the x value of 25. So that's our left bound, that's our right bound. She did it that way. If you would have used the function, just look at your domains here. We start at 0 and we finish at 25. and all of these times match up, so we value in between 0 and 25. So either way would have worked. All right. Now, range, a little bit harder. The range is our lowest value to our highest value in terms of y. So our ranges are y. So Nico, what do you think our smallest y value would have been? Good. So we said 0 was the smallest y value. And then what is the largest y value that we reach? Good. And then 21 is the largest y value that we reach. Okay. So here's the biggest value that had a value of 21. Here was the smallest value, had a value of 0. Good. All right, the increasing intervals. Notice we start to increase right away. Even though we switch functions, don't we continue to increase after that? So we increase right away, starting at 0. And we continue to increase until we hit this big black dot right here that I'm making larger and larger. So we would have increased starting at 0 until, if you follow my pen here, that x coordinate would be 17. So from 0 to 17 we increase, but we also increase again over here at the end. That little line segment starts at 23. And that line segment ends at our end of our domain of 25. All right, so with that being done, do the decreasing interval. We did that one with me. Do the decreasing interval. Make sure we remember how to write that. All right, I'll do this in yellow. We start to decrease here. This is the start, and then we continue to decrease until we hit this point. So we're just writing the interval for this yellow section there. So again, in terms of x, so we start at this big black dot. We start to decrease at 17. And then Ahmed, don't let me down, Ahmed. Where did we stop to decrease at? Good. And then we stop decreasing right in here. That is at the x value of 23. All right. All right. Good. All right. Letter E. Answer letter E. See what you get. Find f of 13. Okay, for f of 13, we have 4 different parts to this, right? So I labeled this 1, 2, 3, and then 4. We have 4 different functions that we could use. If I want to figure out f of 13, Cam, where does 13 fit? In function 1, function 2, 3, or 4? Good. 13 would fit in this window, in this domain. So we're plugging 13 in right here to that function. All right, so when you did that, what'd you get, Cam? Good. And that should give us 9. All right. Same thing with the next one. You got a good day working right now. You got a good day. Now you just stay muted and everything's good. Yep. Just survive these next 7 minutes without me calling on you and you're good. All right. F, find f of 20. So again, if we look at subfunction 1, 2, 3, and 4, find where the x value of 20 fits. So 20 fits right in here. So you're now taking 20 and plugging it in for this x right there. And then we want to evaluate that. This one we might want to do because the little negative's in front, so I don't have a lot of room to operate here to keep this on our screen. All right, so take our 20, plug it in, we get a negative, and then the 20 minus 17, and then add the 21. So that should give us a 3 on the inside with a negative out in front. And then add your 21. And you get 18. Okay. And then the last one, this also I'm not write your answer down. At least do this real quick. It's our last one. We got a minute. Write what you think this answer is. Why do you 4.5? So here's what this is asking, Bisher. When f of x equals 9, we're looking to see when does the graph or the function have a y value of 9. So let me clean all of this up here. Oh, I don't want, shoot, what was I thinking there? Shoot. What was, yeah, good call. Maybe, Ahmed. Let's just do this. What was 9? F of 9. It's 12.6. Okay. So 12.6. I hit that and it jumped my page. Undo button or the back button? Yeah, that's what I did, and it jumped me. But we're good. I think we're good right here. So here's what we're looking for right now: is when does y equal 9? So go to your y-axis, right? Here's your y-axis. Get my pen to work. And find on the y-axis where we have a y value of 9. All right, and that would be right here. So what we're looking for is when does our graph have this y value? So wouldn't that be right here? Oh, I screwed this up too. Now I'm flustered. It should have been 12.6. Maybe not. No, not. We're good. We're good. We're good. What y value did that have on this graph when we connected these guys? Also, look at this answer right here, right? Doesn't f of 13 equal 9? And the question is asking us, when do we have a functional value of 9? Well, doesn't that happen at 13? So what we're looking for in this is an x value where we get a y value of 9, and that's got to be a 13. So if we look right here, notice how that line that I drew in has a y value of 13 when we hit this y value of 9. All right. Vischer, what you did is you did this as if it said f of 9. If it had said f of 9, then we're going to take 9 and plug it in right here because that fits, and we're going to plug a 9 right into here. That's what you would do for f of 9. What we were looking for is we don't want f of 9. We want to know when f is equal to 9. All right, so just kind of keep those things straight. All right, that is it. You do finally get some homework. We haven't had a whole lot of homework this week. It is for you guys with the packet. You're just going to do page 19 through 20. So it's just the next 2 pages. It actually is very, very, very similar to the 2 sets of notes that we just did. So you can model these from the previous couple pages of notes that we just did in class. So 19 through 20. If you don't have the packet, then if you just go to Canvas, it'll say the homework where it always says it in your assignments. And the assignment would be embedded in there for you to print or look off of your screen and write it on a blank piece of paper. All right, so whichever one of those options works, that's what you're going to be doing. All right, so that's through Tuesday night. If you have any questions, we can talk about it. We're going to review on Tuesday, and then we'll take a quiz on all of this on Wednesday. All right? All right, that's all I got. All right, have a good weekend, and we'll see you guys on Tuesday. Have a good long weekend. Kim. I'm not. I got that down pat. I'm not even plugging in my other camera right now because my computer is so... Oh, I better stop recording, although I'm frozen. My computer is having such a hard time with anything right now that I'm not even plugging in the other camera. Class-wise? Yeah, everything's the same. We just... No school Monday.